enzyme as a catalyst. Now remember, we have to think about this word catalyst. A catalyst is something that speeds things up. What's it speeding up? Oh man, my iPad's really struggling here. Okay, what's the catalyst speeding up? A chemical reaction, right? Remember how this works, right? First, we have an enzyme and a substrate. So let's label those. I'm going to use black here. Let's say this purple molecule is our enzyme, and this other molecule, the yellow molecule, is our substrate, right? They fit together. Does anybody remember that spot where they fit together? The active
site.
Oh, you're good, Jenna. Active site. Boy, I'm having trouble here, but no surprise. Active site, right? They fit together, and so look what happens. The substrate is getting stressed, right? We know stress, right? When you're stressed, you feel like you're about to fall apart, right? Like your brain is going to fall on the ground. You're stressed, right? So because the enzyme is stressing it, right? Then at the end, our substrate becomes different, and we call that a product. Look at that. Look at what I wrote there. That's really silly. Let me try again. Product. Almost. There it is. Okay. So the products, right? And look, the enzyme is still the enzyme, right? It doesn't change at all, right? It's like a hammer. The hammer causes the nail to change, right? But the hammer stays the same. And so remember, we said that enzymes speed up reactions by lowering the amount of activation energy. They lower the activation energy. And so we can look at this on this graph. Remember, we said we start over here. It's like a race. We start over here. We finish over here. If we have to run up the big hill, that's going to be slow. It's going to take a while. But if we can take a shortcut with the enzyme, this is fast. And we get to the finish line faster. And so that's what enzymes do for us. They stress our substrates so that we can get from the start to the finish of the reaction very quickly. Okay? We talked about a little bit more when we talked about enzymes. We didn't just talk about how they work. We also said that they're affected by things like pH, temperature, and concentration. Yeah, of course. Yeah, you're going to screenshot it? Great. Okay, so explain how factors such as pH, that's how acidic something is, temperature, that's how hot something is, and concentration, that's how crowded something is, can affect enzyme functions. Okay, so a couple of things here. Bigger enzyme concentration makes faster reactions. So let's say bigger concentration, faster reactions. Remember, we said if you show up and you're going to build a house and you have lots of people that are going to help you, but you only have one hammer, you're not going to build a house very fast, right? You got to have lots of hammers. The more hammers you have, the faster you get it done. The second thing we said was pH and temperature can change the shape of the enzyme, right? So let's maybe underline pH, temperature, change shape. If the shape of the enzyme changes so that now the hammer doesn't look like a hammer anymore, is it still going to be good at pounding nails? If I burn the handle off, is that hammer going to work anymore? Not as well, right? It's going to take longer to work with it. Or say I put it in an acid and the metal part melts away. Then it's not going to work, right? It's going to be just like a stick that I'm whacking nails with, right? It's going to take longer. And so if that happens, we can't perform the reaction. And so that means it's slower. It's being slow. Okay? Jenna, how's our time? 7 minutes? I think we're just going to keep going, if that's okay.
It's 8:48.
Okay, let's just talk a little bit about number 2. Energy organelles. Energy organelles are places where these chemical reactions are happening. Does anybody recognize this brown one that looks kind of like a football?
Oh, the mitochondria.
Good. Does anybody remember what's the chemical reaction that happens inside of it? Close, not mitosis. Cell, what is it, Isabel? Good guess. Respiration. Now, mitosis and meiosis, that's on the next test. So not tomorrow's test. So don't need to have to worry about that for right now. But boy, I hope I can write. Okay, good. Nope, I can't write. So I'm just going to do this. And that series of dots and letters represents the word respiration. Okay, this other organelle is also important. It's found in plants. Does anybody recognize it? Ordinarily, when I write the name on the screen, it gives it away, but not this time. Go ahead, Chris. The chloroplast. And does anybody recognize, or does anybody remember what the reaction is? Photosynthesis. You got it. That's where photosynthesis happens. So those are two important organelles, right? Organelles are parts of the cell that have specific jobs to do, and these are places where chemical reactions are happening. Brandon, you good on that? Okay, one last thing to do, and that's to talk about how energy reactions cycle. So the keystone says that you have to be able to compare the basic transformations of energy during photosynthesis and cell respiration. Let's highlight the two. Oh boy, come on now. I use red for this. Photosynthesis, cell respiration. So those are the two reactions, right? And remember we said carbon dioxide and water are reactants for photosynthesis, and oxygen and glucose are products. Maybe we should write it out. I'm afraid I'm not going to be able. Oh, there it goes. I can do it when I'm zoomed in. So reactants and, oh, come on, products. Nope, can't get a T. Sorry, guys. Reactants and products. The reactants are carbon dioxide and water. The products are oxygen and glucose. Remember, the sun's energy is what supplies the energy. Let's jot that down. That's the word energy. I thought if I don't lift up my finger, maybe it will be better, but it's worse. Let me try again. Yes, much worse. Energy. Remember, glucose is also a high energy molecule. Then those things, oxygen and glucose that were the products of photosynthesis, they become the reactants for cellular respiration. So reactants. And then the products of cellular respiration are carbon dioxide and water. So you see what's happening, right? The atoms are just cycling. The atoms come in and they go around. They just get pushed back and forth all day long. So what I've written here in the middle is atoms cycle. Atoms cycle. Okay? Notice that the energy does not cycle, right? The energy comes in as sunlight and it comes out as ATP. And remember, ATP we said is like the gasoline that powers our enzyme tools. Right? It's needed by our enzymes as gasoline. It powers the chemical reactions that keep us alive. Okay? The last little bit was about ATP as an energy storage molecule. ATP stores energy. Do you guys remember where? Is it in the atoms or the bonds? In the bonds. Let's remind ourselves what this looks like. I'm going to draw a rectangle here. Let's call this ATP. And the thing that's special about ATP is it's got 1, oh boy, 2, 3 phosphate groups, right? Triphosphate. And remember, we said it's the bonds where the energy is stored between the phosphate groups. And so let's jot down energy stored. Okay. When we make those bonds, we store energy. Remember we played with the mousetrap? When we set the mousetrap, we store energy. And then when we trigger the mousetrap, we release the energy back. That's ATP, right? When we make these high energy bonds, we store energy. And then when we break those high energy bonds, we get the energy back. It's kind of like a battery, right? We store energy in our battery in our phone, but eventually it wears off, right? Or wears out. And then we can recharge our battery, right? And store energy again. Yes, I'll do that. I'll take KB-8 because we're out of time. And so let's go ahead and submit this.